Next, let's move on to the interesting part, that's result extraction. I'll go to results tab. So the first step is to make the load combinations. Unlike other softwares where you make the load combinations before the analysis, so if you alter any load combinations, you need to rerun the analysis, but that's not the case in MIDAS Civil. You can make the load combinations after the analysis. So I'll click on load combinations. So here you can give any name and select the load case, like the static load cases and the results of the construction stage. CS indicates the results of the construction stage. So these are all the results of the construction stage, starting from dead load till the summation. So you can select them and type in the relevant factor so that you can make your own combinations based on the code, or you can auto generate. Okay, I'll close this. I'll open a model where I have already made the load combinations to save time. So these are the load combinations that I have made according to the table 1 of BS 5400 part 2. So you can see the temperature, uniform and the gradient and the SLS combinations. I took the envelope of the 4 combinations where the factors are given in table 1 of BS 5400. So I took these factors for my combinations. So I made ULS overall and SLS overall as envelope. You have different options here: add, envelope, absolute and SRSS. I'll click close here. First I'll go to the reactions. I'll click on reaction, force and moments. So here you have the dialog box to switch between the construction stages. Suppose I've selected CS6. So for each stage results you can view from here. You have to select the stage and the relevant load case. So if you see here, so these are the results that are generated for the construction stages, like the dead load, SIDL and crash barrier. We took it from the dead load, like we distinguished in the analysis control. So thereby SIDL and crash barrier got created. And then the tendon primary and tendon secondary. So what do you mean by tendon primary is the forces, the member forces that are caused by the tendon pre-stress forces, whereas the tendon secondary forces represent the member forces resulting from the tendon pre-stress force acting in an indeterminate structure. Likewise, you have creep primary and creep secondary. So primary represents the effects due to the deformation and forces required to cause the creep strain, whereas the creep secondary refers to the effects caused by the creep in an indeterminate structure. Likewise, shrinkage secondary and shrinkage primary. So summation includes the addition of the dead load, SIDL, crash barrier. So tendon primary, tendon secondary, creep secondary and shrinkage secondary till here. So all the addition would go up to the CS summation. So I'll select CS summation. So you can select the component, FZ and click values and click apply. So these are my reactions in CS6 at the end of CS6 at the last step. So you can turn on the legend. So you can see the maximum and the minimum reactions at which nodes. So I'll go to post CS. So these are my construction stage results. So you can individually see the results and the reactions. I'll switch to post CS. Click. So in post CS, so as you have made the combinations, you can click this 3-dot button to see the combinations, like this combinations where suppose in SLS1 comp, so you have selected the construction stage results. That means at the end of the construction stage, whatever the results that are there, you have made a combination accordingly so that you can utilize them in the post CS. So in post CS I have made a SLS combination. I'll go to SLS overall, select FZ component, I'll click apply. So these are my reactions. I'll change this load case to ULS, click apply. So these are my ULS reactions. If I wanted to see in the tabular format, I can go to results tables. So all of this results would be automatically tabled out. So I'll go to beam or the reaction. So we are seeing the reaction. So I'll click on reaction results table. So here it will ask you for the load case. I'll select ULS, click OK. So these are my reactions for different components. Next we'll go to the deformations like the displacement contour. So I'll click apply. I'll turn off the values. This would be the hidden option, so you can see the displacement contour, how it's varying throughout the length of the bridge. Close this tree menu too to see the results. Next, let's check out the beam diagrams. I'll go to forces, beam diagrams. So I'll select SLS overall, MY component, and I'll click apply. So these are my bending moment diagram for the girders. So I'll go to ULS, click apply. So you can see the maximum moment. You can change the units to kilonewton meter. So the maximum moment in the girder is 5890 kilonewton meter. To see them in the tabular format, I'll go to results table, beam forces and stresses. So I'll select the ULS overall. I'll click OK. So you can see the MY component, the major bending moment component, in the table format. So you can right click and select here view by maximum value item, and select MY component, select the ULS case, click OK. So the table gets sorted out to show you the maximum MY value. Next, let's see the beam stresses. I'll go to stresses, beam stresses, select ULS, select SB component, click on apply. Similarly, we can see the beam stresses diagram. You can select the component, click apply. So this would be my stress variation. You can change it to Newton mm. Next, let's see the tendon losses. The software will calculate the tendon losses based on the pre-stressing information that we have given previously. You can go to results, tendon loss. So you can select the tendon group and the construction stage and click apply. So the software will give you the stresses after immediate loss, elastic deformation loss, relaxation, creep and shrinkage loss, and give you the ratio. So you can get it in the stress format as well as the force format. Similarly, we can see the bearing forces. I can go to results tables, go to elastic link, select the load case. So these are my bearing forces for the ULS case. Next, let me show you a powerful feature of MIDAS Civil, which is called as moving load tracer. So this will trace and graphically display the vehicle loading condition. So this is an extremely useful feature when we wish to find the loading condition that creates the maximum or minimum values for all of these influence lines. Suppose I select beam forces and moments and select MV max, HA and HB 30. I'll give the key element as 28. So 28 element is this and diaphragm. Select the MY component and click apply. So this is my loading position of the vehicle for the maximum bending moment at that location. So we can select different elements as a key element. Suppose I select 147. So this is my girder element. I type in 147. I'll select MY component to be maximum. I'll click apply. So this is my vehicle loading position. Even you can convert the vehicle load position into a static load case. So you need to generate the file and then go to MCT command shell. Suppose I select this file. So I'll copy. I'll go to tools. I'll go to MCT command shell. So this is the text command shell of MIDAS Civil. I need to paste it and click run. Click yes here. So you can see a new static load case with this vehicle loading position, and the load is applied.